Okay, so in this video we're going to talk about prime elements. So we say that if we have a commutative ring, what should it mean to be an element is prime? Well, a non-zero element p in our ring, which is also a non-unit. Units, the problem with units being prime is units divide everything. So we don't want a unit to be a prime number. When we were talking about the integers, we avoided units by demanding that our primes be bigger than 1. So that was us avoiding units. And now this is us avoiding units, saying non-unit. Which is a non-unit is called prime if what? Well, if P divides a product, then P divides one of the terms in the product. Great, so that's what it means to be prime. It's just the exact same definition as in Z. We just have to be a little bit more careful specifying a non-unit and then copying the rest over. All right, let's do an example here. Let's look at Z4. Let's look at the primes in Z4. Okay, now to be a prime, we have to be a non-zero element first. So let's list our non-zero elements. Cool. And now let's notice here that this guy is a unit, 1 is a unit, and 3 is a unit. They're both their own multiplicative inverses. So of the 3 elements there, only one of them has a chance of being prime. And it turns out that this guy is prime. Where's my gold color? Here we go. This one's prime. And let's go through how one might show that. All right. So let's suppose 2 divides a product in Z4. We need to show that 2 divides one of the terms in the product. Well, what does it mean to divide? Well, it means that there exists some other element of Z4 such that A bar B bar is 2 bar C bar. Great. Now what? Well, we can write this as an inequality of elements in Z4. And what does it mean that AB bar is the same as 2C bar? Well, it means that they define excuse me, the same equivalence class in Z mod 4. In particular, their difference is a multiple of 4. So this tells us that, let's write it like this, AB minus 2C, if we take that representative, those integer representatives, this is some multiple of 4. Great. Now what? Well, where's my colors? Here we go. This is even. This is even. And this guy must therefore be even, because if it was odd, then odd minus even is odd. Okay, but we have a product of 2 integers, and that product is even. Well, this tells us then that either A is even or B is even. Great. Now, what else? What does that tell us? Well, this tells us that A is 2K. I already used a K, didn't I? Dang it. A is 2M, run out of letters. Or B is 2N. But if we look at what's happening down in Z4, this tells us A bar is 2 bar times N bar, or B bar is 2 bar times N bar. In particular, this tells us that this one would tell us 2 divides A, and this guy would tell us 2 divides B. Now that was kind of a long way of going about this problem. There's a much easier way of going about this problem, and it's to look at the multiplication table. So let's do that as well, just so we have it. Multiplication tables are very helpful. I'm going to start dropping the bar notation. I think we're past it now. All right, so the multiplication table for Z4, you know, we know how to do this. It's not unfamiliar. 4, I guess, is 0, right? And Z4, great. 2 times 3 is 2. 3 times 2 is 2. And then 3 times 3 is 1. Cool. All right. So the guys that 2 is a factor of are going to be precisely the ones, let me go back over here. They're going to be precisely the ones that are multiples of 2, right? So for 2 to be a factor of u have to be a multiple of 2. And the multiples of 2 are here on the either third row or the third column. So these are our multiples of 2. So for 2 to be a factor of u, a factor of a product, it has to be either 0 or 2, because those are the multiples of 2. So we have to look at all of the possible products where we get either 0 or 2, and we ignore the 0. We're gonna ignore the first row in the first column. So all of the cases where we have either a 2 or a 0 are only they happen to only be, in this case, the third row or the third column. In particular, whenever you're a multiple of 2, you have to be, well, you have to be just exactly 2 times something. You're never going to get 1 times something else unless it's a 2 is 2. 1 times 1 is 1, and 1 times 3 is 3, and so on. So this table actually tells us something. It tells us the only time 2 is a factor of a product is, well, when one of the terms is a 2. Or is 0, but even in that case, well, I guess or is 0, but everything goes into 0. Okay, but one of the terms is a 2. That's exactly saying that 2 divides you. Okay, so that's saying that the term that is equal to 2, well, it's just honestly just equals. Every number goes into itself. So this would tell us that, well, 2 would divide that term, whatever the term is. That's another way of seeing it with the multiplication table, but you can also appeal to these sort of divisibility arguments.